Hello all, today let's see about the power supply in a X-ray machine. The primary function of the power supply of an X-ray machine are to provide a low voltage current to heat the X-ray tube filament, generate a high potential difference to accelerate electrons, and two transformers lie within the electrically grounded metal housing called the head of the X-ray machine. Tube current. The tube current is the flow of electron through the tube. The milliampere is the measurement of the number of electron moving through the filament. The number of electron passing through the cathode filament can be controlled by milliampere. Adjusted on the control panel of the X-ray machine. The numerical MA setting on the filament current control refers to this tube current, typically about 10 milliampere, which is measured by the milliammeter. Tube voltage. The voltage of the X-ray tube current is controlled by the kVp adjustment on the control panel. The two circuits used in the production of X-ray are a low voltage filament circuit and a high voltage circuit. The filament circuit uses 7 to 10 volts and is controlled by milliampere setting. The high voltage required to accelerate the electron as they move from cathode to anode for that high voltage circuit of 65 to 70 kVp used to generate X-ray in X-ray tube. The actual voltage used on X-ray machine is adjusted with auto transformer. By using kilovolt peak selector, the operator adjusts the auto transformer and convert the primary voltage from the input source into the desired secondary voltage. The selector's secondary voltage is applied to the primary winding of the high voltage transformer, which boosts the peak voltage of the incoming line current up to 60,000 to 1,20,000 volt. This boosts the peak energy of the electron passing through the tube to 60 to 120 kilo electron volt and provide them sufficient energy to generate X-ray. The kilovolt peak dial select the peak operating voltage between anode and cathode. The electric current can either be alternating current or direct current. In the dental X-ray machine with AC circuit, during the reversal of the direction of the current, X-rays are not produced. The term cycle in AC is the flow of current in one direction and then reversal and current flow in opposite direction. There are usually 60 cycles per second in most of the AC circuit. In a dental X-ray machine using AC, there is reversal of polarity in the X-ray tube 60 times per second. When the direction of the current is reversed, the tungsten filament becomes the positive pole and the tungsten target becomes the negative pole. During the alternating 1/120 second, when the current is reversed, X-ray are not produced, as there is no movement of electron to the target from the filament, or in other words, there is a blockage of current from traveling across the tube. Countering this reversal is called rectification. As the dental X-ray tube is designed to produce this effect, it is said to be self or halfway rectified. In full rectification or full wave rectified circuit, even the negative half of the circle is used for the production of X-ray. In this machine, X-ray are not produced in pulses but as a stream of X-ray. A timer is built into the high voltage circuit to control the duration of the X-ray exposure. Tube rating and duty cycle. Each X-ray machine comes with a tube rating chart that describe the longest exposure time the tube can be energized for a range of voltage and tube current values without risk of damage to the target from overheating. Duty cycle relates to the frequency with which successive exposure must be long enough for heat dissipation. A typical duty cycle is 1:60, meaning that one could make a 0.25 second exposure every 50 seconds. Thank you.